In the summer of 1969, NASA made history. Well, yes, up here, of course. But way, way down here, too. Down 2,000 feet under the surface of the ocean. Starting off the coast of Florida, 6 aquanauts drift along inside the Gulf Stream for 30 days. This is the Ben Franklin, a 50-foot submersible designed by Swiss explorer Jacques Piccard and his team of engineers. The mission of the Ben Franklin is to explore the Gulf Stream, not by powering its way through it like a military submarine might do, but to enter it and become a part of it. The Ben Franklin will drift passively within the core of this massive current, observing and gathering scientific data along the way. The crew will collect continuous observations on drift speed, water depth, water temperature, salinity, marine life in the stream, and conduct 3D photo mapping of the continental shelf. As the days extend into weeks, the crew of the Ben Franklin makes exciting scientific discoveries and observes amazing sea life. While at the same time having to endure sudden surges in the current, abrupt changes in the seafloor, and malfunctioning support systems that begin to make life inside the sub very uncomfortable. On August 14, 1969, after 1,400 miles and 31 days spent drifting within the Gulf Stream, the Ben Franklin splashes up some 300 miles off Nova Scotia, Canada. The Ben Franklin and the Apollo 11 missions were perhaps the greatest expeditions of their kind and ended a decade of incredible technological achievements. The findings from the Ben Franklin mission provided a wealth of information that is still being used to this day and helps provide a better understanding of the Gulf Stream and its role in weather and climate. This influence becomes abundantly clear each year as hurricanes tear through the Atlantic coastal region. The warm water of the Gulf Stream often increases the intensity of hurricanes. That's when the impact of ocean currents can very literally hit home. NASA studies the ocean from a very different perspective, using satellites in space that can make measurements of many key ocean factors, such as ocean color, temperature, salinity, and many more that influence the ocean, such as winds and sea ice. Ocean currents are also closely linked with our atmosphere. The exchange of heat between the ocean and the atmosphere drives the atmospheric circulation over the entire globe. Ocean currents on the surface and the deep ocean circulation also redistribute heat absorbed by the ocean and allows the ocean to act as our planet's thermostat, helping regulate the temperature of Earth. The ocean and atmosphere are just two components of a complex global system of give and take that impacts Earth's overall climate. From the work done over 40 years ago by the Ben Franklin mission to the work being done today by its satellites, NASA's study of Earth systems is contributing to a better understanding of global climate change, its causes, effects, and consequences.